Neurons are the most important brain cells that function to generate and transmit information. They are electrically excitable cells, so they are able to produce electromagnetic wave. What is electromagnetic wave? First, let's see what is a simple wave. Look at this graph. Here we have x-axis that represents the time measured in seconds, and we have y-axis that represents the amplitude. In the brain, we measure it as microvolts. This is an amplitude. This is the maximum strength of electric field. So, if we assume that the non-excited neuron default electric field is here, then amplitude shows how activated the neuron is. In other words, this is the power of the wave. The next thing that we need to know is a cycle. One cycle is a full pattern of a wave. If we mark a point anywhere in the wave, like here, the peak, and follow the wave pattern until we get to the same position again, we have one cycle. The number of cycles tells us a lot about the wave, which brings us to the next term, frequency. Frequency comes from a word frequently. What happens frequently in an EEG is the occurrence of the cycles, right? So, frequency shows how many cycles happened per second. It is measured in something called hertz. So imagine, if we start counting the time from here, and until here is 1 second, we need to just count the number of cycles. Here we have 3 cycles, so this wave is 3 hertz. So from what we understood, the higher the frequency is, the faster the wave is. And the opposite, the lower the frequency, the slower the wave is. Also, with the amplitude is the same. The higher amplitude we have, the stronger wave we have. And the smaller amplitude we have, the weaker wave we have.